Imagine waking up to a world where your phone has no signal, the internet is dead, ATMs don't work, banks are frozen, planes are grounded, and city lights have vanished in a single global blackout. It sounds like the start of a Hollywood apocalypse movie, but this nightmare could be triggered not by war, hackers, or even aliens, but by an invisible storm from the sun. Could one solar event really upend our entire civilization? And if so, how close are we to the next catastrophe? Today, we're diving into the heart of a cosmic threat that's rarely in the headlines but lurks over our ultra-connected lives: solar superstorms. How do they work? What can they do to our world? And, most crucially, are we ready to face the next one? To understand why scientists, emergency managers, and even Wall Street are losing sleep over the sun, let's rewind to a time when the world was powered by steam and copper wires, the year 1859. At dawn on September 1st, 1859, an English amateur astronomer named Richard Carrington was staring at the sun through his telescope, sketching sunspots onto paper. Suddenly, he observed a blinding flash of light erupting from the solar surface. A singular outbreak of light, which lasted about 5 minutes, he later wrote, not knowing he had just witnessed the first recorded solar flare, a blast so powerful it would be etched into history as the Carrington event. Within 18 hours, billions of tons of magnetized plasma, a coronal mass ejection, erupted from the sun, racing toward Earth at unimaginable speed. The collision with Earth's magnetic shield set off the most intense geomagnetic storm ever recorded in modern times. Telegraph systems worldwide went haywire. Operators received shocks, paper trails caught fire, and in some cases, messages continued to be sent even after batteries were disconnected, powered by electrical surges from the storm itself. Waves of glowing auroras painted the night sky, visible in Rome, Cuba, and even as far south as Colombia, places that rarely, if ever, see such spectacles. But here's the twist. In 1859, the world's technology was limited to wires, railroads, and ships. The total economic disruption was mostly felt by telegraph operators and a few startled city dwellers marveling at the sky. There were no satellites, GPS, or internet. As Martin Connors, professor at Athabasca University, explains, the effects are on electromagnetic systems, and that's basically what our whole life is now, as opposed to back then. Fast forward to today. Our world is an intricate web of satellites, power grids, undersea cables, and data centers. Everything, from food supply chains to international finance to emergency services, relies on electromagnetic infrastructure. If a Carrington-magnitude solar storm struck now, the stakes would be colossally higher. Because of the development of our society, such events could be more devastating than they used to be. That's a certainty. We're much more vulnerable now, Connors warns. Let's get technical for a moment. What exactly causes these solar superstorms? The sun is not a static ball of light. It's a boiling cauldron of plasma, crisscrossed by magnetic fields that twist, tangle, and sometimes snap. Every 11 years, the sun's magnetic activity peaks in what's called the solar maximum. At these times, sunspots, dark, cooler patches caused by concentrated magnetic energy, increase dramatically. These areas are breeding grounds for solar flares and coronal mass ejections, CMEs, gigantic blasts that can hurl billions of tons of matter and embedded magnetic fields straight toward Earth. Most solar flares pass by harmlessly. The Earth's magnetic field deflects or absorbs them. But when a CME is big enough and aimed just right, when its magnetic polarity aligns with Earth's in a certain way, it's like unlocking the front door to our planet's electromagnetic systems. The storm's energy then surges along power lines, through transformers, and even into pipelines, potentially frying electronics and causing catastrophic blackouts. How rare are these events? Scientists have searched for answers in everything from Arctic ice cores to the rings of thousand-year-old trees. It turns out the Carrington event wasn't even the worst case. In 774 AD, a Miyake event, more than 10 times stronger, left its fingerprint in global radiocarbon spikes. In 2023, researchers in the French Alps discovered evidence of a solar storm 14,300 years ago that dwarfs them all, establishing a terrifying new upper limit of what's possible. As Ksenia Golubenko of the University of Oulu states, this 14,300-year-ago event establishes a new worst-case scenario for solar storm risk assessment. Let that sink in for a moment. If we think Carrington was the big one, nature may have far more devastating tricks up its sleeve. So, how likely is a Carrington-sized hit in our lifetime? Opinions differ. Some studies estimate the odds at 1 in 1,000. Others say the risk is as high as 12% to 25% over the next decade. The problem is our records are short and space weather is unpredictable. On Earth, as a single planet around a single sun, it's hard to assess the rare things that our sun does, Connor says. Still, experts agree, it's not a matter of if, but when. In fact, we've already had near misses. In March 1989, a less powerful storm caused a 9-hour blackout across Quebec, plunging millions into darkness. In July 2012, a Carrington-class CME missed Earth by just a cosmic hair, passing our orbit with the planet safely out of the way. Earth had a lucky escape, scientists later concluded, and the global public barely noticed. But luck is not a strategy. Modern civilization's vulnerability to solar storms is growing by the year. The 2024 Gannon storm hammered the point home. Precision agriculture systems lost GPS for hours, costing over $500 million in lost crops and logistical chaos. As Tamitha Skov of the Aerospace Corporation notes, the agriculture industry took a hit due to GPS vulnerabilities during the Gannon storm, and that was just a moderate event. The threat is twofold: the sheer energy of these events and our increasing dependence on fragile tech. The Carrington flare released energy equivalent to 4 was 10 Rs 32 ergs, a number so immense it defies imagination. The U.S. government estimates that a modern repeat could inflict $2 trillion in damage in just the first year, 10 times the cost of a major hurricane, and with far less warning. Here's the chilling part. Our early warning systems are woefully inadequate. Right now, NASA and NOAA's satellites give us about 30 minutes notice on the critical direction and strength of a CME. That tiny window is all the time utilities and satellite operators have to act before the magnetic tsunami hits. Imagine trying to shield the entire internet, global banking, and every power grid on Earth in the time it takes to order a pizza. And then there's the communication breakdown. A government tabletop exercise in May 2024 exposed the gaps. Agencies struggled to coordinate, protocols were unclear, and vital information lagged. As Ian Cohen, APL Exercise Science Lead, put it, the tabletop exercise highlighted key research and observational gaps in space weather preparedness. The Space Weather Research and Operations Center echoed the concern. A lack of communication protocols hampers effective response to extreme space weather incidents. But the problem extends beyond official agencies. Most businesses, local governments, and the public have no idea how to respond, or even how to recognize the early warnings. Meanwhile, the next solar maximum is approaching, with experts anxiously watching sunspot data and magnetic readings. So what exactly would a modern Carrington event do? Picture this. The storm slams into Earth. Satellites are blinded or knocked offline. GPS systems fail worldwide. Planes can't navigate. Container ships pause mid-ocean. The agriculture sector's machinery reverts to manual mode. Power surges ripple through continental grids, overwhelming transformers that melt and explode in showers of sparks. Blackouts sweep across continents. Water pumps, heating systems, and hospitals struggle on emergency power. Tens of millions lose access to banking, communication, and digital maps in seconds. As markets panic and supply chains seize up, social disorder threatens to follow. And the scary part? It could take weeks, months, or even years to repair. Some transformers have multi-year manufacturing lead times. Entire economies could be paralyzed. The National Academies of Sciences put it bluntly. A solar storm of Carrington magnitude could potentially cost nearly $2 trillion in damages today. Yet we're not entirely helpless. Agencies like NOAA, NASA, and their international partners are racing to close the warning gap. The Space Weather Follow-On, SWFO-L1 mission, launching in 2025, promises more detection time. Power grids are being slowly retrofitted with surge protectors and new protocols. But in May 2024, a severe geomagnetic storm again exposed our weaknesses, disrupting radio communications and showing how rapidly society's basic functions could unravel. Still, progress is slow. Critical infrastructure often depends on old technology. Funding and public awareness are limited. And as the solar cycle ticks toward its next maximum, the clock is running out. Press and media are becoming more knowledgeable, and emergency management authorities are increasingly planning for space weather storms, NOAA's Sean Dahl observes. But is that enough? The question hanging over all of this is chilling. If the next big one is already overdue, possibly lurking in solar activity this decade, will humanity's preparations be enough? Or are we, for all our modern technology, just as helpless as the telegraph operators of 1859, watching the skies and hoping the storm passes us by. As experts race to develop new defenses, the bigger mystery remains. Can we predict or prevent the next Carrington event, or will it catch us off guard? In the next half, we'll explore the cutting-edge technology, bold policy moves, and wild new ideas that could decide the fate of modern civilization. So, with the lessons of the Carrington event illuminating our path, let's turn our eyes to the future, a future filled with both daunting risks and the chance to shape our destiny in the face of solar fury. Imagine for a moment waking up one morning to news alerts pinging your phone, if they even still work. Solar scientists have detected a monster coronal mass ejection racing toward Earth, a blast of charged particles moving at millions of miles per hour. Within hours, satellites begin to blink out of service. Air traffic controllers lose touch with flights. Financial markets grind to a halt as electronic transactions seize up. Across cities and countryside, the power grid stutters and then fails, plunging millions into darkness. It sounds like science fiction, but as we've learned, it's a scenario rooted in very real physics, and a scenario that experts warn is not just possible, but sooner or later, inevitable. One chilling fact. In 2012, a CME similar in scale to the Carrington event missed Earth's orbit by just 9 days. The difference between normalcy and worldwide disruption was a cosmic hair's breadth. And as Dr. Ksenia Golubenko of the University of Oulu puts it, recent discoveries set the bar even higher. This 14,300-year-ago event establishes a new worst-case scenario for solar storm risk assessment. Carrington, it turns out, may not even be the upper limit. Nature has already dealt even stronger blows in the ancient past. But what would a superstorm mean for us today? Unlike in 1859, almost every aspect of daily life, banking, communication, healthcare, even food supplies, relies on complex, interwoven systems highly sensitive to electromagnetic disruption. It's not just about colorful auroras. The real threat is the invisible electromagnetic pulse pulsing through transmission lines, melting transformers, scrambling satellites, corrupting navigation networks, and putting emergency services to the test. Recent history offers alarming previews. In May 2024, the so-called Gannon storm caused GPS-dependent tractors to weave drunken patterns across farmland, costing the agriculture industry an estimated $500 million. Radio communications faltered as the ionosphere turned turbulent. And in a tabletop exercise that same month, government agencies admitted to major gaps in their ability to coordinate a rapid response. Ian Cohen, who helped lead the exercise, summed it up. The tabletop exercise highlighted key research and observational gaps in space weather preparedness. So, what might happen if a true Carrington-level event, or something bigger, strikes? There are several scenarios, each more sobering than the last. First, the worst case, a direct hit. Today's tightly coupled power grids are vulnerable to induced currents from geomagnetic storms. Transformers, complex and expensive to replace, with lead times exceeding a year, could burn out by the thousands. Major regions could lose power for months. Hospitals, water systems, and food supply chains would reel. City after city might plunge into chaos not from cosmic violence itself, but from the loss of the fragile technological infrastructure that undergirds civilization. Satellites, too, are at risk. From GPS to weather, television to military intelligence, our eyes in the sky sit directly in the firing line. A strong CME can fry electronics, degrade orbits, leave us blind not just to real-time navigation or TV shows, but also to coming storms or global emergencies. As Tamitha Skov of Aerospace Corporation warns, the agriculture industry took a hit due to GPS vulnerabilities during the Gannon storm, and that was just a small taste of what's possible. Communications would be among the first casualties. Modern society depends on everything from cell towers to undersea cables, all linked together by clocks synchronized via space-based systems. One powerful solar storm could throw that global network into chaos. Emergency services could find themselves in the dark, literally and figuratively, just when they're needed most. The National Academies of Sciences has pegged the potential first-year cost of such a disaster at nearly $2 trillion, with ripple effects that could linger for years. But the future isn't just a story of disaster, because we're not helpless. While the risks are daunting, they also drive innovation and cooperation on a global scale. For starters, our ability to see these storms coming is improving. Agencies like NOAA and NASA now operate a ring of satellites devoted to watching the sun's every mood. The upcoming SWFO L1 mission, soon to launch, will give us earlier, more precise warnings, potentially hours rather than just minutes, to react. But let's be realistic. Even the best current technology gives us only about 30 minutes warning of the most dangerous aspect, a CME's magnetic field orientation, just before it hits. That's barely enough time for grid operators to implement emergency protocols or for airlines to reroute polar flights. Unless we invest in even better forecasting and unless agencies coordinate far more closely, we'll always be playing catch-up. This is why exercises like the one held in May 2024 matter. They reveal not just the gaps in our technical capabilities, but the crucial importance of clear, practiced communication across all levels of government and industry. As the Space Weather Research and Operations Center bluntly put it, a lack of communication protocols hampers effective response to extreme space weather incidents. That message is starting to get through. As NOAA's Sean Dahl notes, press and media are becoming more knowledgeable, and emergency management authorities are increasingly planning for space weather storms. Awareness is growing, and with it, the chance to avert catastrophe through preparation instead of panic. So what can we do? What can you as a viewer do in the face of such overwhelming cosmic forces? First, realize that this isn't just a problem for scientists, engineers, or government officials. Space weather affects all of us. Whether you're a business owner relying on electronic transactions, a farmer using precision GPS, or simply someone who enjoys a hot cup of coffee made possible by a functioning power grid, your life is intertwined with these invisible solar storms. Second, demand preparedness. That means asking your local utilities and government, do they have a space weather plan? Are critical infrastructures hardened against geomagnetic surges? Is there a backup plan in place for communication and emergency services if satellites blink out? Public awareness and pressure drive investment into hardening key systems, such as installing resistors and transformers that can withstand induced currents, or creating redundancies in satellite fleets. Third, take individual and community-level precautions. Have a basic emergency kit, water, food, basic medical supplies, battery-powered lights. Consider simple things like a non-electric radio to receive emergency broadcasts. Keep copies of important documents offline. These are the same smart steps you'd take for any disaster, but with a solar twist. Remember that electronics themselves can be at risk. And don't forget to look out for your neighbors, particularly those who rely on medical equipment or are otherwise vulnerable. Social resilience, the ability of communities to pull together and support each other, can make all the difference when centralized systems falter. On a broader scale, there is a growing movement among scientists and policymakers to treat space weather with the same seriousness as earthquakes, hurricanes, or cyber threats. That means funding research into how geomagnetically induced currents can be managed, supporting international agreements on satellite coordination and early warning systems, and conducting regular drills, just as we do for storms and fires. Here's the paradox. The more advanced our technology becomes, the more fragile it is in the face of extreme space weather. But that same technology, if thoughtfully designed, could empower us to ride out even the sun's worst tempests. We're in a race against the universe's clock, striving to predict and prepare before the solar storm of the century finds us off guard. So, is current preparation enough? The honest answer is, we're making progress, but we're not there yet. Efforts are underway, monitoring, forecasting, emergency planning, infrastructure upgrades. But recent events and research highlight sobering gaps in coordination, communication, and investment. The difference between a global crisis and a historical footnote may yet come down to whether we use the time we have to build resilient systems, share knowledge, and learn from the past. As the sun approaches its next solar maximum, continuing into 2025 and beyond, these questions become more urgent. Will we heed the warnings of history and science? Or will we let haste, complacency, or budget cuts leave us vulnerable to a cosmic storm that doesn't negotiate or wait for us to be ready? The secret fact, rarely discussed outside research circles, is that the worst-case scenario, a storm far more powerful than the Carrington event, has already happened in the distant past, 14,300 years ago. That event would have dwarfed anything in recorded human history. It's a humbling reminder that we are not, and may never be, immune to the whims of our star. But by preparing, learning, and acting before disaster strikes, we can tilt the odds in our favor. So the next time you see an aurora dancing overhead, remember, those ribbons of light are a gentle signal from the cosmos, asking if we're ready for something bigger. The choice is ours. Will we rise to the challenge? If you found this video eye-opening, share it to raise awareness, because the more people understand this invisible threat, the stronger our collective response will be. Subscribe for more deep dives into science, technology, and the forces that shape our world. And if you have questions, ideas, or personal stories about living through blackouts or geomagnetic